Hello friends, welcome back to our YouTube channel. If you like this video, please like, share and subscribe. I'll share our videos commanded by our experts, so let's begin.
If you like, please like, share and subscribe. So let's begin our today's topic. Let's begin.
Punchy AI allows engineers to write code 10 times faster than ever before. But that speed has a cost. Vulnerabilities are being injected into the digital ecosystem at that exact same velocity. Standard security operations still rely on static detection rules and a method called fuzzing to catch these flaws before they are exploited. Fuzzing is a brute force approach. It works by bombarding software with random, chaotic inputs to see if any specific combination causes the system to crash. But as AI-generated code becomes more complex, these random tests are struggling to keep up with the sheer volume of logic paths that need to be checked. To solve this, Google DeepMind and Project Zero collaborated on Big Sleep. This AI agent is designed to navigate code like a human researcher, using deduction rather than brute force. The system recently reached a milestone by autonomously discovering a critical zero-day vulnerability in SQLite. This is a database engine used by almost every modern operating system, and the flaw was found before any human researcher caught it. To secure the modern internet, we are moving away from blindly testing software and toward systems capable of active, targeted analysis. Big Sleep doesn't just wait for a crash. It actively reads the codebase to understand how the software is built. Using the reasoning capabilities of Gemini models, the agent maps functional relationships between code segments to understand their context. This mapping allows it to follow specific logic paths and deduce where a flaw might hide, bypassing random inputs. This reasoning is currently being applied to millions of lines of open-source code, where Big Sleep has already flagged dozens of vulnerabilities in libraries like FFmpeg and ImageMagick. This shifts security testing from mindless stress tests toward a targeted analysis of the code's internal logic. We can see this logic in action by looking at the specific discovery made within the architecture of SQLite. Big Sleep identified a complex stack buffer underflow, where a program pulls data from the bottom memory boundary, breaching containment. By holding the software's broader context, the agent recognized the exact conditions triggering this underflow, something traditional fuzzing missed. The entire process, finding, analyzing, and reporting this critical flaw, required zero human intervention. In this case, an autonomous system succeeded where both human researchers and traditional automated tools had previously failed. While finding bugs faster is progress, it creates a new problem. Human developers will eventually be overwhelmed trying to write patches at the speed the AI finds them. To address this, Google introduced CodeMender, an agent built on Gemini DeepThink models. CodeMender doesn't just flag the bug, it rewrites the code to fix it. This diagram shows the logic. It identifies a vulnerable loop and reconfigures it into a secure circuit. In its initial tests, the agent proactively provided 72 security fixes to open-source repositories, some of which contained over 4 million lines of code. These capabilities are now being integrated commercially through the Google AI Threat Defense Framework. Enterprise security teams can now pair Gemini's code generation with threat intelligence to scan and patch their own vulnerabilities at machine speeds. By connecting discovery and repair, these systems move security closer to an automated loop, one that aims to patch vulnerabilities before they can be exploited. Modern software engineering is operating on a new timeline. Artificial intelligence is now integrated into the development process, writing and deploying code at a rate that has overtaken human capacity. This shift is quantifiable. With AI assistance, engineers produce code 9 to 10 times faster than the human baseline. But productivity isn't alone. Because output has multiplied tenfold, the vulnerabilities and structural flaws embedded in that code increase at the exact same pace. Standard security operations are built around manual dashboards and static detection rules. These legacy systems are now struggling to process the sheer volume of new code being committed every hour. This creates a mathematical bottleneck. Human security teams are physically unable to keep up with the speed at which AI-generated code is being deployed. The pressure on defenders is doubling because AI isn't just being used to build software, it's being trained to break it. Google DeepMind and Project Zero recently introduced Big Sleep, an autonomous AI agent designed for continuous, high-speed vulnerability hunting. In its first real-world application, Big Sleep discovered a critical zero-day vulnerability in SQLite, a database engine used by billions of devices, before human researchers even knew it existed. The AI identified a specific stack buffer underflow. This occurs when a data pointer moves backward past the bottom boundary of a memory stack, unintentionally exposing sensitive, adjacent data to potential exploits. This creates a dangerous vacuum. With AI writing flawed code at 10x speed and agents like Big Sleep finding those flaws instantly, human developers can no longer patch systems fast enough to maintain security. Solving a speed gap this wide requires a response that operates at the same layer as the code itself. Google DeepMind's solution is CodeMender, an autonomous agent built to handle the remediation process without human intervention. CodeMender uses Gemini deep think models to provide the reasoning capabilities necessary to understand complex software architecture, rather than just flagging simple syntax errors. This flowchart highlights the transition. While traditional security relies on a human to write and deploy a patch, CodeMender autonomously rewrites the code to fix the flaw the moment it is discovered. Security is no longer just an alarm system, it becomes a self-healing mechanism that operates at machine speeds. To test this at scale, Google deployed CodeMender into the massive, unorganized world of open-source software infrastructure. During its testing phase, the agent successfully navigated and analyzed codebases containing up to 4.5 million lines of code. The results were immediate. CodeMender created and upstreamed 72 distinct security fixes directly into dozens of widespread open-source repositories. One concrete example involved LibWeb, a popular image compression library. CodeMender didn't just find a hole, it modified how the code is compiled. It added annotations forcing compilers to include bounce checks, rigid safety parameters that physically prevent memory breaches, leading to exploits. This proves the agent can proactively harden software architecture at a scale that human teams are mathematically incapable of matching. At the enterprise level, modern security operations centers are currently facing a volume of automated attacks that traditional defense strategies cannot stop. This is where the Google AI Threat Defense Framework comes in, integrating these autonomous agents into commercial security. The framework links Gemini's code generation with the intelligence networks of Mandiant and Wiz, creating a unified defensive layer. This allows enterprise teams to scan, triage, and deploy patches across their entire network entirely at machine speeds. Defending a modern enterprise is no longer about human reaction times. It's about deploying intelligent systems to outpace malicious automation. The gap between human reaction time and AI generation speed has become insurmountable. As the speed of discovery and exploitation becomes a function of compute rather than human effort, traditional manual patching is now mathematically obsolete. Autonomous remediation agents like CodeMender act as the necessary counterweight to this shift, providing the only viable path for maintaining digital security. As AI accelerates the cycle of software creation, adopting autonomous remediation is the only way to secure digital infrastructure before an exploit can be launched.